Hey math kids, today we're going to talk about how to graph some non-functions in um, Desmos for your final project. So right here I have just a basic circle graphed. You can see the equation on the left. It's just x squared plus y squared equals 1. This last term, the 1 in this case, represents the radius squared. So if we take the radius and we square it, we get this number. So the radius on this one is 1, because if we square root 1, we get 1, and that's how we can see that. So I can, if I want to make it 3, I need to change this to a 9. So see how it goes from 0 to 3, and if I do a 16, that's going to get me to 4, and then 25 is going to get me to 5, right? Okay, so going back to that, going back to the original. Now, if we want to start moving it around, like moving where the center is, everything works counterintuitively. So if we look at this one, so here I'll change this to a 1 so it doesn't. So what I did is I moved 1 to the right and I moved 2 up. So notice how it's counterintuitive. The negative actually moves it in the positive direction. And so if I were to change these two positive signs, see how they move in the negative? They either move left or down. Okay. Once again, we can still change the radius. We can make it 3 by changing it to a 9, 4 by 16. We just need to take the square root of whatever number we plug in. Okay. And that's about it for circles. So if we move on to let's see, if we move on, so if we start changing the x value and the y value at a different rate, we're going to get like a oval, which is called an ellipse in math. This still works kind of like the radius. It's a little bit harder to get like exact because we're changing at two different rates. But if we make this number bigger, it becomes bigger. So just let it, use guess and check essentially on that one. Now, if we wanted to get bigger in the x direction, we can make this bigger. Or, whoops. Let's see. Oh yeah, it's counterintuitive, sorry. So like 1 over 7 is going to make it bigger because I make a smaller number. Or you can just use decimals. So 0.009 is going to make it really big. But if I go 99999, it's going to make it really small. Okay. And then if we want to affect the y direction, it's the same thing. So if I do 1/5, it gets bigger. But if I do 5, it gets smaller. So once again, you just make your oval if you want it wider in the left to right direction or wider in the like up and down direction. That's how you do it. Now this one is like, we can just move it left and right. It works just like the circle. It's counterintuitive. It's moving the center. So this one we moved 1 to the right because the x was changed by a negative, so it goes in the positive direction. The y was changed in a positive way, which means it goes in a negative way on the graph. So once again, if I want to move this up, to the right 5 from the center, from the origin, moved it over to the 5. And then if I want to move this up, I would have to say like -2. So this goes to the right 5, up 2. Once again, it works just like the circle. Okay, now if we just put a negative sign on either the x or the y, we get something called a hyperbola. So it's kind of a weird, it's kind of like two parabolas in a sense. It's a little bit different than that, but the center is right here. It's not even on the curve. And so if we want to start moving this around, okay, so this is one where we put, the one that we can see, there's a negative on the y, so it's going to be kind of a left to right or like a horizontal hyperbola. If we do this one, where we put a negative on the x, it's a vertical hyperbola. And once again, we move it the same way. So if I just had x, the x value is at 0. If I just had y, the y value of the center is at 0. So if I want to move it to the right 10, I'm just going to say -10. So see how it moved there. And then if I want to move it down 5, I'm going to say +5 because it's counterintuitive. plus on the y goes down, negative on the y goes up, positive on the x goes left, negative on the x goes right. If you need additional help, please come to Math Lab. Until then, calculator.